can start the session. So welcome everyone. Welcome to this session on Microsoft Fabric. Today we have with us Brian, who is a Microsoft Most Valuable Professional, Microsoft MVP, as well as Microsoft MCT in data and analytics. He is also principal architect at FellowMind. He will be guiding us today about warehouses and Microsoft Fabric. So welcome Brian. Welcome to this session.
Thank you. And I guess I just get started and I will share my screen. So just hang on and I will start the presentation. Let me see if I can do this directly in Teams. That could be funny. Sometimes that does not work. So let me see if I can do that. I'll just share my screen then. So it doesn't work. So there you go. And let me go to slide 1 and present. So there you go. Thank you for having me. And yes, that is right. Today in this session, I will going to talk about the warehouse service inside Fabric and how to use it and what to know around the good and the bad things around the warehouse service in Fabric. A short thing about me. My name is Brian. I'm from Denmark. I'm the principal architect of data and AI in a company called FellowMind. If you want to link up, you can find my LinkedIn profile right here. I also have a blog where I try to write about my thoughts on the warehouse and all the Fabric things happening. The slides from today you will find on my GitHub profile. There's a repository called Slide Decks where you can find the slides immediately after this session. As you just heard, I'm a Microsoft MVP on the data platform. I'm a fast track recognized solution architect on Power BI and also a Microsoft certified trainer. So enough about me, and let's get on with what we're going to talk about today. First of all, I'm going to show you an overview of what happened in Fabric after Build, because Build was last year from Microsoft Build, and we got some amazing updates all over the place inside Fabric, and I will shortly walk you through those, and then we can tag along and watch the service around warehouse and other services. How do they compare? What are the differences, and how to choose. Then I will talk about the T-SQL features inside Fabric, because there are some things that you need to take into account when working with the T-SQL landscape in Fabric. Security and recovery, how do we do that in the best way? And last but not least, source control and semantic models inside the Fabric warehouse service. So without further ado, last week we got the community event, sorry, not the Microsoft event called Microsoft Builds, and here they announced a huge amount of new services, both around the data warehouse, data engineering, data factory, science, and all that stuff. We also got a new hub called Real-Time Hub, which is out of this scope for this session today, but. Today I will focus on the data warehouse and the OneLake, how they compare and how we can also perhaps utilize Copilot inside the warehouse. Because last week we also got a new Copilot feature. We got Copilot for data warehouse, which now compiles into 5 different Copilots in Fabric for data factory, warehouse, data science, real-time, and for Power BI, of course. The data warehouse Copilot can help you write your T-SQL languages and scripts. It can also help you with understanding what are the consequences of doing stuff. And the last feature, perhaps the best, is that it can actually help you comment and optimize your T-SQL scripts, so the next reader or developer of that script can see what does the script do and how does it actually execute the code behind. If you stumble upon a script in a data warehouse that is not commented or documented, then you can also get Copilot to help you understand what is happening if the script is complex. We also got Graph API, GraphQL, and an API service that sits right on top of your data estate inside Fabric, where with a few clicks with the mouse, we can actually now create an API with the GraphQL service, and this can then be used in whatever web service code you are doing, and then all of a sudden we can now begin to build websites and applications based on the GraphQL API in Fabric, which then interacts with the data in your OneLake or your data warehouse. So this service now is now bridging the gap between data and applications. So what are the services that we can choose inside Fabric, and how do they compare to the former services of Synapse and also to Databricks? And I forgot to mention, if you have any questions, please, I don't know, raise your hand, do something, and then write your question in the chat, and then I hope I will be interrupted by the host, and then we can take the questions as we go along. First of all, the data warehouse, it is, of course, storage focuses on the single storage solution called OneLake. OneLake is just the Azure Data Storage Gen 2 with a beautiful UI on top and additional services around failures and recovery and all that stuff, which is why you pay a small markup for your storage inside Fabric. It integrates seamlessly with Azure Services, Azure Data Factory, Synapse Analytics, and all the other services inside Fabric, and will automatically provision the underlying hardware if you need it. If you need more service inside the Synapse warehouse in Fabric, then you will get it. Whatever role you have inside Fabric or inside your data estate, then the data warehouse can be allocated to dedicated workspaces and enable developers, users, and reviewers to collaborate on the data wherever they are. If we compare this to the Synapse part, which we got a few years back, then we are still working in a unified workspace. It automatically starts the underlying hardware that you need, and if you are going inside to the dedicated pool, then you can also get a dedicated compute to handle whatever you need. It uses the Apache Spark dedicated SQL pool, and it also enables you to perform real-time analysis on both structured and unstructured data. The dedicated pool also have the row-level security on security and governance, which enables you to do row-level security directly inside the dedicated pool. You need to do a bit more stuff on the data warehouse inside Fabric, still called Synapse Data Warehouse, but it is still doable inside Fabric. Databricks is perhaps the biggest competitor to Fabric, both warehouse and Synapse. Databricks is highly scalable. It can easily handle huge amounts of data, and it scales horizontally. I have seen comparisons between Fabric and Databricks for handling standardized data sets, and even though Databricks is perhaps faster, or you can make it faster, then the Fabric warehouse is almost at par in speed, but it is far more cost effective going around handling the data and processing the standardized data sets. Of course, we need to do more testing, so this is not an announcement of Fabric is more cost effective than Databricks, but just be aware that you might see a minor cost decrease when you are using Fabric compared to Databricks. Databricks also works with notebooks, and the integration in Databricks is seamless with all other Azure services that you have for storage inside your data estate. A comparison between the warehouse and the lakehouse, then perhaps you have seen this table in other versions before, but the warehouse works with only structured data. It works with the SQL language. You have schemas and tables. You have object level security, row level security, and column level security. And you're using the T-SQL language to handle, manipulate, and work with your data. The Lakehouse, on the other side, is also able to handle semi-structured and unstructured data. In order to work with the data in your Lakehouse, you need to do notebooks and PySpark. The Lakehouse handles files, folders, and tables. And at Build, we also saw in Las Vegas a few months ago, we saw a sneak peek that Lakehouse will eventually get schemas inside your tables. So that is an upcoming thing going forward in the roadmap for the Lakehouse. Lakehouse has row level security and table level security. And of course, for the languages, you use Spark, Scala, PySpark, or Spark SQL. Whatever architectural approach you have to your data models or your data estate, Fabric has your back. Warehouse integrates easily with those services wherever you need them. And if you need to choose between the warehouse and the Lakehouse, then I would always, for a new installation with new people, I would always go for the Lakehouse. But if you have an installation that you need to migrate into Fabric, Warehouse is the way to go, because then you can migrate all your SQL workloads or your T-SQL scripts or your stored procedures and your views into the data warehouse, and then you have a faster transition from wherever you are into Fabric. If you have SQL savvy people inside your organization and would like to start in Fabric, then Warehouse is also the place to go. No matter what you choose between Warehouse and Lakehouse, you will get the same performance, the same usability, and the same output. You just have different tools to work with. The Warehouse is still using the Polaris engine, just like we saw in Synapse. And the Polaris engine is, in short, it is a stateless compute where we have disconnected the compute power with the storage. In Fabric, we have the one leg for the storage. In Synapse, we have the storage accounts, but it is more or less the same thing. And when you need the compute, then the compute is given to you or utilized through either Synapse or Fabric when you do your select or when you do your data manipulations inside the warehouse. The stateless compute is also giving us a few drawbacks where we no longer have the possibility to do identity columns. We no longer have possibilities to do other stuff in SQL, but I'll get back to those differences later on. The Polaris engine is still using the distributed query processing, as you see here in the middle, whereas you connect to the SQL frontend, you actually connect to a SQL server inside Fabric, and then the backend SQL pool is given to you when you need it, and that backend SQL pool is then connected to OneLake to read out the data that you need from your Parquet files and other services. So the T-SQL surface area, which is the name of the Fabric workload that you open up to work with your T-SQL language, it covers some of the supported syntax of the standardized T-SQL language, but not everything. You cannot do, as I saw here, as I'm showing you here, you cannot do an alter table, so you cannot add a column, alter a column, drop a column, or you cannot modify your table once it has been created. If you really need to alter your table, you have to create another table with another name, add the column that you need, and then load the data from the old table to the new table, and then perhaps rename that table afterwards. It is a bit of a cumbersome work, but it can be done with hacks and other stuff. As I said, identity columns is not a thing in Fabric. You cannot do it because we don't have identity column needs some dedicated compute when you handle all your data sets. And as I just showed you, you cannot get dedicated compute in Fabric. You will get the compute when you need it. So that is why we can't do identity columns. Truncate is still not working in Fabric. I hope it will get there, because if we need to empty a table, we need to do delete. And as perhaps you know then that the delete statement is a fully logged statement, whereas the truncate statement is only minimal logged. So the logs around what is happening inside the database is not as detailed, and the truncate statement will go faster. If we go to the yellow mark here, then create role user is not easy. It is not something a standardized SQL user could do, because you need to do some workarounds in order to get that to work. Merge statements is not working, but you can do that with updates and delete statements. So the merge statement is not there, but if you disconnect the merge and look at it, what it actually does, then you can do it by delete and updates and inserts manually by your own T-SQL ninja tricks. We cannot do recursive queries because recursive queries requires dedicated compute, but we can do queries that connects to each other if we do it in a view, and then based on the known levels in the recursive queries, then we can do just the same amount of the same number of joins on your views, and then you're good to go on building queries that perhaps unfolds a parent-child hierarchy for further on analysis. On the green part, then bulk load is really performant inside the warehouse. No matter how hard you hit the warehouse with data ingestion, then it will adopt it and it will save it according to your needs. You can also set transaction isolation levels, and you have different data management views, dynamic management views, to watch over what is happening inside your warehouse. When we're talking about transaction level and isolation level, then we have three different isolation level. We have the schema stability, where you would just do select statements that is not even logging a table. We just read the data out. Then we have the intent exclusive statement, where when we do insert, delete, update, or copy into, then we get an intent exclusive log for our table, and perhaps other people, other processes will have to wait for this process to end. If we do schema modification, create table, delete table, and all that stuff, then we get a schema modification log, and people might also have to wait. But if we look at the isolation level, then we only have snapshot isolation level, so optimistic concurrency, and that is more or less logs at the table level. And if you need to go through all the current logs that you have in your database, in your warehouse, you have a dynamic management view called dm_tran_logs, as we have in the SQL Server, where you can see all the current logs that are happening inside your warehouse. So please keep in mind that when you do insert, delete, updates, and copy into, you will get an intent exclusive log, and that might interfere with your select statement and your schema modification. And also the same thing with your schema modification might interfere with your insert, delete, update, or select statements. If you do select statements, please go ahead. It is not a problem doing that, and you will not interfere with other people. If we look at what is happening inside the transaction things, then on the left side of this timeline is one user, and on the right side of this timeline is another user. If we look at the left side, then perhaps I do a select statement from several tables, and then while that is running, I have I have one other user or application trying to do insert, updates, or deletes that are initiated on the same tables that I'm doing select statements on. Perhaps hopefully those updates, inserts, and deletes will commit to the tables quite quickly. But the thing is that the select statement actually returns the data as it was when I initiated the transaction. So whatever is happening between the start of the execution of the select statement and the actual result set is not given back to me in the select statement. If we go a bit further and then we look at an update table, if I start to update a row in a table or something, and another application or user starts an update on the same table, but that user has a faster commit than I have, then my transaction will fail, because then the state of the data is not the same as I started it as when I tried to commit it, because the data has now been updated, and my transaction will fail, and I will get an error when that happens. You might see this when you work on a warehouse that has update statements running to build slowly changing dimension type 2 and all that stuff while you are doing your select statements. So perhaps sometimes you will see that your transaction is just being tossed away and disregarded. So you just have to rerun that select statement, and then you will get your result set back. Inserts is just easy peasy. You can do all the inserts that you need, because inserts is not doing a result set back to the end users. So whatever inserts are happening on the same tables is just fine, because the data that is stored in the warehouse is actually just yet another Parquet file in your OneLake. So just inserts is fine. Just go ahead. Inserts will not interfere with each other at all. But if you want to, what happens sorry, let me rephrase that. If we want to load data to the warehouse, how can we do that? Well, by code, we can do copy into from a SQL, from an Azure storage if we want to. We can do a create table as select, also called CTAS, or we can insert into with values or from a select statement. That is also something you can do today on a normal SQL server. And also, of course, we can use the PyODBC or the JDBC connector from notebooks if we want to do that. We can actually also use our pipelines to brute force data into the tables or into the warehouse by the copy activity from either the Azure Data Pipelines or the Fabric pipelines directly inside Fabric. And the new thing inside Fabric is we can actually use our data flows Gen2/Power Query to add data to our warehouse table, because now we have a connector directly to our warehouse, and we can load data, insert data to the warehouse directly from the data flows Gen2 in Fabric with a low-code/no code approach. I need to do this. All SQL operations that you are doing in the warehouse is actually manipulating Parquet files in the OneLake. If you do an insert on update, then you have new Parquet files are being written, and then those Parquet files is being handled by the Delta logs, as you have seen in Synapse and in other services. And then if we do a delete, then I'm actually not deleting the data from the Parquet files. The Delta log has just been added with a deletion vector, which tells the engine that please skip these rows in your next select statement and do not return them back to the end user or the application when they select the data. The deletion vectors are there until you do a vacuum or a cleanup of your Parquet files. Then the deletion vector will be gone, and new Parquet files will be handled inside the OneLake. And then those Delta logs, when they are complete and done, then you can do lakehouse shortcuts from the warehouse to the lakehouse without moving the data. You can just do a shortcut to the lakehouse, and then you can use the warehouse data in the lakehouse. This might be a load pattern for when loading data to your warehouse, and some of you might have seen that the DBT service, the metadata-driven data warehouse service is now supported by Fabric, and there you can declare your SQL loading processes, and you can declare your process for loading tables based on dependencies. So if The DIM customers in this case is based out of both orders, payments, and customers. Then DBT will handle that for you in the correct way in dependencies and load the elements needed before you actually fill up the DIM customers dimension in your warehouse. If you haven't worked with DBT before, I encourage you to give it a shot, because it is quite a powerful tool to build your warehouse processes directly in Fabric. So now we've been talking about the engine, the logs, the transaction levels, and how to load data. But what about all the cost inside the warehouse? Well, whatever you're doing in Fabric, no matter the service, then you are being tracked by capacity unit seconds. Capacity unit seconds for the people who don't know that is actually how many compute second per second am I using in my services. This is both for the warehouse and the lakehouse and the real time and Power BI and so forth. And compute seconds by seconds is actually how many cores am I utilizing per second in my Fabric warehouse. So an example is, perhaps I have an execution of a process that takes 3 seconds, but that process utilizes perhaps 6 cores in my backend. So I have to time the 3 by 6. So I'm actually paying for 18 compute seconds for that single process. In order to get an overview of what is happening, then the Fabric Compute Metrics app is the way to go, where you can see what do I pay for and where does my compute actually end up. As you see here, then the warehouse query is generating a lot of CUs, so a lot of compute units. This is where I pay, and the one-leg compute is not even there. It is only 0.1 compute seconds, so it is actually not even interfering with my charge. But the one-leg compute actually does a lot of work for me, whereas the duration in seconds for the warehouse is highly parallel. So perhaps the one-leg compute in this example has used 11,800 seconds. But the warehouse queries, the end users have only waited 1,360 seconds for this. So you will see that this is more or less a factor of 8 or 9. Sorry. Whereas the parallelized system is starting, and the warehouse is perhaps starting 10 or 9 threads towards my one leg. You can also see how many are using the SQL endpoint, and what are they consuming of capacity units or compute seconds, and in this case 4,000 compute units with a total duration of 1,000 seconds. So here you will see that the SQL endpoint in this specific scenario has parallelized its processes in a factor of 2.5, because the end users are only waiting 1,503 seconds for all processes that has been done in this period of time. But we have paid 4,000 compute units for this process. I hope it makes sense, or else give me a shout. Whatever you are doing in Fabric, you will be exposed to what Fabric called bursting and smoothing. Whereas if you have in this scenario, this is a GIF, I'm sorry, it is doing a lot right now, but this GIF has a limit of 64 compute units, so this is an F64. I am then allowed, if I need it, I'm allowed to burst my execution above the limit for a short amount for a short period of time. But that then demands me or Fabric to actually do the payback, and the payback is shown on the next. There you go. So 7, 8, and 9 is overboosting, and the payback is then all the things that I'm not utilizing after the execution has been done. It's then being taken away from my fabric capacity in the next couple of minutes. So you will never ever end up with a capacity that has just died because you have used all its capacity. You are allowed to boost, but then after the boosting, the smoothing is starting, and then you might see a small decrease in performance when the smoothing is working for you. So it is okay to boost, but you will have to do a payback later on by the capacity units not being so performant. So whatever you're doing in the SQL analysis in the warehouse service in Fabric, you have dynamic management views to help you. You have these 3 to see what are your connections right now, what are your sessions, and what are your requests. And requests is actually also the query text, the select statements, the insert, the updates, the deletes, and these 3 dynamic management views should be a standardized access for everyone working with Fabric and trying to handle the maintenance and the governance and all that stuff around the warehouse service. In order to access these, you need either member, contributor, or viewer access to the Fabric workspace. So readers cannot see these dynamic management views. Around security. Security can be applied in different ways, and we are still waiting for on the roadmap defined service called One Security, where we can define our security on the OneLake level. But here we need to define the security on either the workspace level, on a admin member, contributor, or viewer role, and then they can then access the different warehouses inside the workspace. If we need, we can do granular security levels on tables and views by doing standardized T-SQL languages for grant, revoke, or deny, select, or other processes on those objects. So let's make a thought data warehouse right now. So now we have covered the load, the security, and the compute. So what happens if I have a disaster? How can I recover my data in my warehouse if things go haywire? Well, we have 7 days of automatic availability for restore in place. And then we have, in those 7 days, we can do either relay on the automatic restore points, or we can do user restore points. Then we can always restore in a known good state. And where was I? Yeah, and those known good states are then up to 42 restore points in 7 days. So 7 days for 42 restore points is on average 8 hours per restore point. So every 8 hours during those 7 days, you have a restore point where if things go haywire, if you have dropped the table or something else has gone down the drain, then you can always restore to an automatic restore in place point in time. You can also do user restore points. Those are also a maximum of 7 days availability. You can always create a restore point, perhaps use it before pausing, or use it before significant data modifications like deployments. Around deployments, I will also cover this later, then know that if you have a change in your existing table and you do a CI/CD deployment to your warehouse, then the existing table in the warehouse will be dropped and a new will be created. We are yet to have a CI/CD process where the table is just being added a new column, because as we saw in one of the prior slides, we cannot do auto table add column. So the table needs to be dropped and then recreated. I have done this a few times without remembering that, hey, this table will be dropped and recreated, so I need to use the restore point to go back and then change my CSV process. Sorry, I just have to clear my throat. Let me show you all of this. In the warehouse service, you have also the possibility to do the table cloning. Table cloning is just a copy of an existing table. Nothing is actually, when you clone a table, nothing is actually happening inside the OneLake storage. It is just giving you a metadata pointer to the same Parquet files, as you can see on this bottom image here, that this is a dim event, and then I have cloned it to dim event development. And if I don't touch that data, then I am pointing to the same Parquet files. The second I begin to alter my dim event development, I begin to add, delete, whatever things I'm doing with it, then I will have a different Parquet files being generated in the OneLake. So the clone is extremely fast to do, but the first data manipulation things you are doing on the clone table will take a few milliseconds extra, because then it needs to copy the Parquet files out. This can be done for testing, for development, and perhaps also to do a backup of a table before you do a deployment. I don't know if you know Grant Fritchie. He's from Redgate, and he talks a lot about treat your database like code. Treat your database like code is the idea of that whatever you're doing in your warehouse, please treat it as a code, and there Azure Data Studio database projects has your back, because you can do, I think the current version has just been updated to 1.5 today, or 5 or 1.52. Sorry for that. And here you can handle your database object as code and put it inside Git, and then have automatic deployments between Git and the warehouse, either through GitHub or through DevOps. And again, please bear in mind, you cannot alter tables. So if you have a change to an existing table, that table in the existing data warehouse will be deleted and a new one will be created, and you will lose all your data in that table. So please perhaps do a clone table, or save the data in other ways. When you are done with your warehouse and the tables are ready and the content is there, then when you build a semantic model, then you are utilizing the OneLake for direct table connections. But if you have developed views for your for the baseline data to your semantic model, then those views will default back to direct query, because views are not yet supported. I hope it will be later on. It's not yet supported by the semantic models. So please, if you really want to do the direct lake connection, which is the fastest one to the OneLake, then use tables as your end destination for your warehouse, because then you will be in the fast lane for reading data. The direct lake is using the Vertipack engine from Power BI to read the data from the Delta Lake format in the Parquet files. Views or row level security, object level security will also default back to direct query for the semantic model if you do views, if you do row level security on your tables in the SQL endpoint. Yeah. When you build your semantic models and you create your connections inside Power BI, shown here at the right side of this slide, then you are actually building constraints directly on the warehouse on the default semantic model. So if you build a relationship on two tables, then you're actually also building constraints on the warehouse, so you can watch these. You can see these constraints on the dynamic management view for constraints, and you will see that they are actually creating constraints for in the physical tables on the warehouse. Yes, I think that is it. I have now used 40 minutes. If I have any questions, please let me know, or else I would like to say thank you. If you have any questions, let me know, or I would love to connect with you on LinkedIn. If you scan this QR code, you will be guided directly to my LinkedIn profile. If you have any questions, please let me know now.
So if anyone has any questions, feel free to ask that in the chat box, and Brian would love to answer that questions.
Yes. Let me see if I can I share this slide in another way so I can see the chats in the same format. Just hang on. Present Teams. Present. And the private view, and yeah, I think it is uploading. And I will go to the last slide so I can both see the chat and you guys. So there you go. I don't see any questions or comments. Then I would like to say thank you for having me a lot. I really enjoy presenting at this user group. I know we are a huge amount of distances away from each other. I'm from Denmark, and I think you are on the more eastern part of the world, looking at from a European perspective. So I love to hang out with you guys, and if you have any questions, please reach out to me on LinkedIn. I just saw a comment, share LinkedIn link. Yeah, the LinkedIn link is just at your screen now. If you scan this QR code, you will see the LinkedIn. You will be directly to my LinkedIn profile. So thank you, and have a great
Thanks,
day.
Brian. Yeah, so our community is more in APAC region, India, Singapore, and we have folks joining from these countries, East Asian countries. And thank you so much for taking your time in guiding us about Microsoft Fabric. And I'm sure everyone had a great learning experience today. And we look forward to have you in the upcoming sessions as well. So thank you
Sure.
so much, Brian. Thanks for taking your time.
Thank you, and have a great day, everyone.
Yeah, you too, Brian. Have a great
Thank
day.
you. Bye.
Thank you. Bye. So I'll be sharing the certificate link. I mean a feedback form. You can fill that feedback form, and through which you will be getting the certificate for today's session. So you asked right now the question in terms of cost, is it good to build data warehouse in Fabric? So I think it's better if you connect with Brian on LinkedIn, and you can ask this question on LinkedIn. Like you can DM him on LinkedIn, and you can connect with him, and you can ask this question. And but yeah, thank you so much. Thanks for everyone. Thanks for joining. Let me just share my screen, as well as if you haven't joined our community, then please do join our community. And you can scan this QR code and you can join our community. Yeah, so I have shared my screen, and you can join our community. Yeah, you can scan this QR code and you can join our community either on WhatsApp or on Discord. And I'll also share the link of the community. And Just give me a second, and I'll also share the feedback form. You can fill that feedback form